Hi, welcome to the discussion class of Community Dentistry. First, we'll see about the phases in the history of public health. We have 4 phases here. One is the disease control phase, the health promotion phase. Here in the concept of health centers were quoted in 1920 by Lord Dawson. The names in community dentistry are an important part of the multiple choice questions. The next phase is the social engineering phase, wherein the concept of risk factor was introduced. Risk factor is not the one that causes the disease. It is the one that increases the probability that a person may get a disease. Then we have the next phase as health for all phase, and it was in this phase that WHO had pledged for an ambitious target of health for all by the year 2000. So that was health for all phase. Now we compare the personal health care with the community health care. An examination of a patient is equal to survey in the community. Survey is taking in the data from the community. Then when we examine the patient, we again gather some data from the patient. When we go in for diagnosis of the patient, that is equal to analysis of the data which is obtained from survey in the community. When we talk about treatment planning of the patient, it becomes program planning in community, and treatment in the patient becomes program operation there. Now the payment here becomes finance there, and evaluation of the patient becomes approval of the program in the community. We come to biostatistics. The father of health statistics is John Grant. What was the first name we came across in this PowerPoint? The concept of health center was given by. If you have forgotten the name, I would suggest you to turn back the pages and see the name. We come to the data. Data is of 2 types, that is qualitative data and quantitative data. The names themselves are explanatory. When we say qualitative data, it's something that describes the quality of the data, that is males, females, there can be fat population, thin population. When we say quantitative data, it is the data which could be measured. Herein, when we say measurement, we have 2 types of measurement. One is a discrete measurement which could be counted as these apples are. We can count these apples as 1 apple, 2 apple, 5 apples, right? But we have one type of data which is continuous type of data, which is measured by some scale. We can have 1 millimeter, we can have 1.2 millimeter, we can have 1.25 millimeters. So this is a continuous scale of data. But when we say discrete data, we cannot have 1.2 apple or 1.25 apple, something like that. This is discrete, which could be counted, and continuous, which is measured on a continuous scale. Example is length. From where the data comes? What is the source of the data? We have 2 sources of data. One is the primary data, and other source could be secondary data. When we say primary data, it is a data which a researcher or an investigator goes and obtains from the study population. But the secondary data is obtained from the records which were already stored in either a hospital or some organization. So it is not a first hand data, it is a second hand data which is obtained, that is secondary data. What is a sample? When we are supposed to conduct a research, the best way of conducting a research is to study the whole population, because whatever ultimate result you are getting of a research, you will be applying it to population. Is it possible to study the whole population? Yes, it is possible, but it's very cumbersome, and this study of whole population is called as census. And census is conducted mostly, or you can say only, by government. When a researcher like us conducts a study, he takes a sample of the population, a part of the population that represents the population. This part of the population is called as sample. Now when we say how we select a sample, there are 2 basic ways of selecting sample. One is the purpose of selection, that is a deliberate selection, and second is random selection or probability sample. The names are important. The purpose of selection, wherein we select a population that best suits our study. But this is wrong, because ultimately the result will be applied to whole population, even to the people who do not suit your study. So when you are selecting a sample from a population, it should be a random sample or a probability sample, wherein every individual of the population has equal opportunity to get included in your study. Equal probability of getting included in the study. That is why it is called as probability sample. So you can say if you have a purposive sample, you will select a sample that best suits your study. And that's wrong. You have to give equal opportunity to all the members of the population to be included in the study, and this would be random sample, and this is the correct way of sampling. When we say randomization, we have various methods of randomization. The first one would be simple random method, wherein you take whole population and just take a lottery to select the sample. Or the other way is you can generate random numbers from the table of random numbers, and accordingly you can select the sample. Next we come to systematic random sampling. Systematic random sampling is comparatively easier than the simple random sampling, because here what we do is we select the first unit randomly. That gives the randomization to our sample, and after that we select every nth subject. It could be every third subject, it could be every second subject, or it could be every fourth, fifth, whatever you select. So n value is selected and you select the first sample randomly. So it's like that, first sample you select randomly. It could be any of these. And after that you select every nth sample. So herein we are selecting every third sample to be included until we reach the number of samples we want. Next we come to stratified random sampling. Now you take an example. In a class, if you have 10 girls and 10 boys, and you select the sample by a simple random procedure, you get 6 samples randomly, and it may happen that all the 6 samples which you have selected may be boys. Is your sample representing the population? No. In such a scenario wherein your population exist in certain strata, herein you go in for stratified random sampling. What you will do is you'll divide the class into boys and girls, and you'll randomly select 3 samples from the girls and 3 samples from the boys, and then your sample will actually represent the population. Okay? So population is first divided into groups or strata, and then the simple random samples are obtained from the strata. You have one more example here, the list of clients here. It has Caucasians, it has African Americans, it has Hispanic Americans. So what you do is you divide into strata, and then you take sub-samples from those strata, and ultimately your sample will represent the prime population. Then you go in for cluster sampling. Cluster sampling is a type of stratified sampling, but herein you are not making the strata, but the strata are the naturally formed groups. It could be villages, it could be some geographic areas, or which are naturally present. Okay? That is called as cluster sampling. Then you have multi-phase sampling. Multi-phase sampling is employed when you have a very large population. For example, you are supposed to select a random sample from whole country. Right? How do you do that? So what you can do is you can select the sample in multiple phases. You can randomly select first the states from the country. Then you can randomly select cities from those selected states. Then you can randomly select blocks from those selected cities. And then probably you can select your sample. You have an example here. Population is Shanghai. What you select is 3 districts from Shanghai. And from there again you randomly select blocks from each district. And then you select the residential areas from the selected blocks. So this is how you go in for a multi-phase sampling, and your ultimate population will represent main population. Next, coming to a pathfinder survey. The name itself says it's a pathfinder survey. It is a survey wherein you take in a stratified cluster technique. It's a preliminary survey which we conduct in all the subgroups of the population, so that we come to know that which is the basic group we'll target in our main study. And herein, after we do this study, we also can calculate the sample size which is required for our study, the main study. So what we saw till now was simple random sample, wherein you selected the samples by lottery or by random numbers. Then you have systematic random sampling. What you did here was selected first a random number, and then you selected every nth number, and then you had the stratified random sampling, wherein first you divided the sample into stratas, and then you selected the random samples from those stratas, And you have the cluster sampling, wherein your population was already divided into natural clusters, and you're selecting samples from each cluster. And you had multi-phase sampling, wherein you are taking a big population and then you are selecting randomly in multiple phases. For example, from country you select randomly the states, then from states randomly the cities, from cities the areas, and from areas you select your samples. Okay, next we come to degree of freedom. When we say degree of freedom, first we talk about an unpaired t-test. In unpaired t-test, what we have is a series of data. We have freedom to change all the variables in that series except one. You can take this example. This is the series of data, and out of which these three data, except one, all the other data are independent and can be changed, and this is dependent on the previous three. Now this is just an example. Here in all these variables, if they are added together, they give the value 11. We can change first three, but we cannot change 2 because it will be dependent on first 3 to make this value 11. That shows an example of dependency. So that is what happens in unpaired t-test. We can change all the variables except one. So the degree of freedom in one series is n minus 1. So for example, if we have 4 variables, degree of freedom would be 3. If we have 100 variables, degree of freedom would be 99. But in a paired t-test, when we have two series of data, again we have degree of freedom of only one variable out of the total variables of the two series. So it is like n1 plus n2 minus 1. But the degree of freedom gets limited if we have a data in the form of rows and columns, as we see in here. When we consider a row, in a row, our degree of freedom is restricted to one column less. So it will be like our degree of freedom will be number of rows minus 1. Same happens here, number of rows minus 1. Now same happens with number of columns. So when we say columns, it is column minus 1. So our degree of freedom when we have a data arranged in table is row minus 1 into column minus 1. In this scenario it becomes 3 minus 1, and again we have 3 columns, so we have 3 minus 1 here. So a degree of freedom is 2 into 2, that is 4. Next we come to the measures of central tendency. There are 3 main measures of central tendencies when we talk about statistics, that is mean, median and mode. So first we come to arithmetic mean. Arithmetic means wherein we add all the observation and we divide it with number of observations. So here in this example we have 5 observations, so we take the sum of all 5 and divide it by n, that is 5. So what we get here is mean. Next we have median. Median is a middle value in the distribution when the data is arranged in the order. We take the same example again. What we do is first step we arrange the data in an order. In the central value will give you the median. So now as we see this example here, we had only 5 variables, so it was very easy to calculate median for us. But if you have hundreds and hundreds of variables, it will be difficult to count the median manually. So in that case what we use is a formula. If our n is equal to 5, what we select is n plus 1 divided by 2, that is 3. Third value in an arranged data is your median. So if you have odd number of variables, what you do is n plus 1 by second value corresponds to median. But if you have even number, in case you had 6 values here, what you get is 2 values in the center. In such case, you take these 2 values and you take the arithmetic mean of the central 2 values to get the median. Next we come to mode. Mode is a value that occurs with greatest frequency. You can have the same example here. In the same example, the value that appears maximum number of time will be your mode. So in this example, it becomes 4. In some situation, this mode may be ill-defined, and in such a scenario, we go in for a calculation of mode by using this formula, that is mode is equal to 3 median minus to mean. Be very careful. You have the questions which ask you calculation of mode, and usually the example given is very simple, and you don't usually have to use this formula. You get the mode by just simple calculation, simple counting of the numbers. So whenever you have an MCQ, just don't be very hasty to use this formula, because you will end up into a wrong answer there. Now when we know all these central tendencies, which of these central tendencies would be affected by the extreme values? So for a hint, you can use the same example wherein only one value is changed to make an extreme value. Find out the answer for this particular question based on this example. Here we come to the end of the part 1. In the next part, we'll have the answer to the previous question.